This video I want to show you how to calculate percent composition or mass percent. For example, if we consider ethanol molecule, we have C2H5OH. First of all, we need to calculate the molar mass or molecular weight. We know we have 2 atoms of carbon, 5 atoms of hydrogen here, and we have 1 atom of hydrogen here, so we have 6 atoms of hydrogen and 1 atom of oxygen. So C, for mass of C, is going to be 2 moles times 12.01, which is atomic weight. Hydrogen, we have 6 moles times 1.008. Mass of oxygen, 1 mole, we have 16 grams per mole. So these are the numbers. We just add all of them together to get the molar mass of ethanol. So now if you want to find the mass percent of carbon in ethanol, so here in previous slide we found the molar mass of ethanol. Now we need to see what's the mass of carbon. So mass percent of carbon, we need to calculate mass of carbon in 1 mole of ethanol divided by mass of 1 mole of ethanol. So it means that the molar mass. So in totally we have, because we have 2 moles of carbon in 1 mole of ethanol, so it means that the mass of carbon is going to be 24.02 grams. So 24.02 grams divided by molar mass of ethanol. So 24.02 divided by 46.07 grams multiplied by 100% to get the percentage is going to be 52.14. So that's the mass percent of carbon in ethanol. Now if you want to find the mass percent of hydrogen on oxygen, we do the same thing. Here we have mass of hydrogen in 1 mole of ethanol divided by molar mass of ethanol. So if we go back here, we have for hydrogen we have 6.048 grams in 1 mole of ethanol. So we can say 6.048 grams divided by molar mass of ethanol, which is 46.07 grams times 100. So it's going to be 13.13%. The mass percent of oxygen. Mass of oxygen in 1 mole of C2H5OH. We have it here. We have 16 grams divided by molar mass. So 16 grams divided by 46.07 grams times 100% is going to be 34.73. Now we can see here, because we have only 3 elements in this ethanol. So if we add 34.73, 13.13, and 34.73, we must get 100%. Now let's see another example. Calculate the mass percent of each element in C10H14O. So here again we have 3 elements. We need to calculate the mass of carbon, hydrogen, and oxygen. So we have 10 carbons, so 10 moles times 12.01 is going to be 120.01 grams. 120.1 grams. Mass of hydrogen in 1 mole is, we have 14 hydrogen, so 14 times 1.08 is going to be 14.11. Mass of oxygen in 1 mole is going to be 1 times 16 gram per mole, so we have 16 grams. So if you add all this, you get the molar mass or molecular weight, which is 150.2 grams. So now let's see how to calculate the mass percentage for each of them. So mass percent of carbon, in all denominators we have the molar mass. Carbon here we have 120.1, so 120.1 divided by 150.2 times 100%, we have 79.96%. For hydrogen we have 14.11, so 14.11 divided by 150.2 grams times 100%, we get 9.394%. And mass percent of oxygen, we have 16 grams here, so 16 grams of oxygen divided by 150.2 grams times 100%, so we get 10.65. So as you see here, when we add all these 3 numbers, we get the 100%. Now let's see the last example. Calculate the mass percent of each element in C14H20N2SO4. So here we have 1, 2, 3, 4, 5 elements. So first of all, we need to calculate the molar mass. We have 14 carbons, 20 hydrogen, 2 nitrogen, 1 sulfur, and 4 oxygen. So 14 times 12.01. For hydrogen, we have 20 times 1.008. Nitrogen, we have 2 times 14.01. Sulfur, we have 1 times 32.07. And oxygen, we have 4 times 16. So we get these numbers, and if we add all of them together, we get 312.4 grams, which is the molar mass of this compound. So now let's calculate mass percent for each element. So for example, for mass percent of carbon, we need to divide this number by this number. For hydrogen, this number by total number. The molecular weight, for nitrogen, we need to divide this one by the molecular weight. Sulfur, divide this one by molecular weight, and oxygen, same thing. So now let's see the results. So mass percent of C, we have 168.1 divided by molar mass times 100. Mass percent of hydrogen is 20.16 divided by molar mass times 100. Mass percent of nitrogen, 28.02 divided by molar mass times 100. Mass percent of sulfur, the mass of sulfur divided by molar mass times 100. And mass percent of oxygen, we have 64 divided by molar mass times 100. So we have 53.81, 6.453%, 8.969%, 10.27%, and 20.49%. Again, if we add all these numbers, we get 100%.